Hi everyone, I am David Cho, Technical Director at EDOM Technology. Today I am pleased to introduce NVIDIA Jetson Thor. NVIDIA Jetson Thor currently has two products, the T5000 and T4000. Today we'll focus on introducing the Jetson AGX Thor T5000. The T5000 delivers up to 2070 teraflops of AI performance. Equipped with 2,560 GPU cores and 96 tensor cores, supporting 128 gigabytes of memory and 4x25 gigabit Ethernet networking. It's designed for extreme computing and large-scale AI scenarios. Simply put, the T5000 pursues ultimate performance, meeting AI applications across different levels to make installation more intuitive. The Jetson AGX Thor Developer Kit places all I/O ports on one side, making it easier for developers to connect sensors and organize cables. External interfaces include two USB Type-A, one RJ45 Ethernet port, one HDMI, and one DisplayPort, two USB Type-C, one QSFP slot. It is worth noting, this is the interface for the Holoscan Sensor Bridge primarily for optical fiber cables, as well as a micro-fit connector for expandable power. On the bottom of the developer kit, there is an M.2 key M slot with a built-in 1 terabyte NVMe Express SSD and an M.2 key E slot with a built-in wireless card. On the other side, there are three buttons: Power, Force Recovery, and Reset. Allow for quick startup. NVIDIA Jetson AGX Orin is already powerful, with 275 TOPS of computing power, easily capable of handling most AMR and edge devices. But NVIDIA Jetson AGX Thor pushes everything to new heights. Its AI computing power reaches 2070 FP4 teraflops, 7.5 times that of Orin, CPU performance improved by 3.1 times. Energy efficiency increased by 3.5 times. Its I/O throughput is even 10 times higher than Orin. It also features 128 gigabytes of memory. Power consumption can flexibly adjust between 40 to 130 watts. In short, Jetson Thor is not just an evolution, it's a complete overhaul of the large-scale AI models that previously relied on data centers, allowing them to run smoothly directly at the edge. For developers, quickly setting up a development environment is crucial. Simply plug in the Jetson Thor development kit and install the latest JetPack 7.0 via the SDK Manager. To install, prepare a computer running Ubuntu 22.04 or a later version. Then run the SDK Manager and set AGX Thor into recovery mode. Connect to the host via Type-C. Confirm Jetson AGX Thor is automatically detected, then follow the guided steps. This time we selected to install all components. Pre-config allows presetting username and password. The default storage device is NVMe Express SSD. The installation process takes about 1 hour, and then it completes. Afterward, the AGX Thor Developer Kit automatically reboots. When you see the crown logo on the desktop, it means the installation succeeded. JetPack 7 not only provides OS and drivers, it also integrates CUDA, TensorRT, and various AI and multimedia acceleration libraries. So developers can immediately start building robotics and edge AI applications. To achieve true physical AI, NVIDIA has built a complete development environment consisting of 3 computers. First, DGX handles training and fine-tuning of AI models, providing powerful computing power to enable the model to take shape quickly in the data center. Second, move into Omniverse and Cosmos, simulating and validating the model in virtual environments to ensure its stable operation in the real world. Finally, deploy the model to Jetson Thor for real-time edge inference running directly on the robot or in the field. Through training, simulation, edge inference, we complete AI robotics development. The VSS demo consists of 2 parts. The first part is the computer vision CV pipeline. We use DeepStream with GroundDino to detect videos. When it detects that a custom object does not meet the conditions, it will automatically output the video to VSS for analysis. The second part is VSS analysis. The system sends the segments to Cosmos, Reason 1.1 VLM for inspection, using a yes-no format. It converts results into true or false status for real-time alerts. For example, in a warehouse scenario, we can set up specific objects such as people and define trigger events like What is the worker wearing? Which rack are they climbing? Is the environment safe? Is the worker wearing a hard hat or safety vest? Once an event occurs, the system displays the relevant footage in the VSS UI, allowing users to ask further questions based on the video content. Let's take a look at the Holoscan Sensor Bridge demonstration. It not only brings image data to the GPU for processing, it can also fuse radar, LiDAR, and RF sensors, even ultrasound or medical imaging and other sensor inputs to perform AI inference and decision-making in a low-latency, synchronous manner. Holoscan runs on NVIDIA Jetson embedded devices, AGX industrial edge platforms, and even AGX, or data center class systems without rewriting code for each platform. Typical application scenarios include medical devices, medical robotics, scientific computing, and industrial inspection. In short, Holoscan Sensor Bridge enables multimodal sensor data, truly real-time, synchronous, and scalable, making it ideal for latency-sensitive, complex, or safety-critical applications. Now, let's introduce the GR00T N1.5, NVIDIA's latest general-purpose humanoid robotics foundation model. It integrates vision, language, and motion generation, allowing robots to understand the environments, follow instructions, and complete tasks autonomously. For developers, this is a groundbreaking tool. Compared to its predecessor, boasts comprehensive upgrades in language understanding, object recognition, and motion planning. This means developers no longer need to recollect extensive data for each scenario, allowing robots to learn quickly and adapt in unprecedented environments. They no longer follow programmed processes, but can now demonstrate reasoning, judgment, and flexible manipulation. Another key advantage is cross-embodiment adaptability. Cross-embodiment means across different robot forms. The same model can be applied to different types of robots, from humanoid robots to autonomous mobile platforms and to industrial robotic arms. Developers don't need to retrain models for different hardware. They can share the same intelligence and experience across multiple platforms. This significantly reduces the development threshold and integration complexity, allowing researchers and engineers and even startups to more quickly transform concepts into practical solutions. In summary, GR00T N1.5 is more than a technical upgrade. It redefines the approach to robotics development, allowing developers to focus on innovative applications rather than repetitive infrastructure. It lays the foundation for the true intelligence of the future of general-purpose humanoid robots. GR00T N1.5 is not only capable of driving humanoid robots, it can also quickly adapt to different robotic platforms. In these examples, we chose the LeRobot SO101 robotic arm to showcase its cross-embodiment capability. Our task was desktop cleaning. We collected data through human demonstrations and fine-tuned GR00T N1.5 to the SO101. The entire process requires only a small amount of data and a simple setup to complete model training. Next, we conducted an open-loop evaluation, comparing the model's output actions with real-world records to confirm it has learned the correct logic. Finally, we deploy the model to the SO101 robotic arm, allowing it to clean the desktop in the real world. The power of GR00T N1.5 is that it can be trained once and used across multiple embodiments. For developers, this means with less data and in less time, they can quickly migrate intelligence to new hardware platforms, accelerating the transition from prototype to production. In real-world application scenarios, Jetson Thor makes the value of AI tangible. In smart factories, VSS can capture and tag anomalies in real time, while Holoscan Sensor Bridge supports high-speed inspection and quality control, ensuring stable production line operations. In medical imaging analysis, Holoscan combined with large language models provides physicians with real-time, accurate decision support, speeding up clinical decisions. In the field of humanoid robots, Jetson Thor can handle perception, planning, and decision-making, simultaneously achieving truly real-time interaction. So robots are no longer just tools, but intelligent collaborative partners. The arrival of Jetson Thor represents a significant leap forward in physical AI. It brings the powerful computing power once available only in the cloud to the core of robotics. Combined with a comprehensive software toolchain, it enables developers to implement complete AI workflows at the edge. For developers building the next generation of intelligent robots, Jetson Thor is more than just a platform. It empowers robots with a brain and nervous system, enabling them to fully demonstrate their perception, thinking, action capabilities, accelerating real-world implementation and bringing AI robots into the real world faster.